Underground highways could move cars faster than a jet plane. The Boring Company wants this future to be real. This idea sounds wild, but Elon Musk's venture truly believes in it. Traffic jams are a nightmare for millions of people worldwide every single day. Many cities lose billions of dollars annually due to lost productivity and fuel waste. For instance, Los Angeles commuters spend over 100 hours stuck in traffic each year. This wasted time has a significant economic impact. The company aims to dig many tunnels deep beneath our cities. They plan to make these tunnels affordable and super efficient. Their goal is to fix surface level congestion one tunnel at a time with a rapid transit solution. The technology behind it involves specialized drilling machines. These machines are designed to work much faster than traditional tunnel boring equipment. One major claim is that they can dig tunnels 14 times quicker than current industry standards. This incredible speed increase is a huge part of their strategy. It means projects can be completed in a fraction of the usual time and expense. Another big promise involves cost. They say their tunnels will be 10 times cheaper to build. This is achieved through smaller tunnel diameters and also increased digging speeds. Less time digging means less labor costs for construction crews. These are staggering numbers if they can truly achieve them consistently across large-scale projects. The reduced diameter itself saves enormous amounts of material. A traditional subway tunnel can be 30 feet wide, accommodating large trains. Their tunnels are usually 12 feet wide, designed for smaller vehicles. This 60% reduction in width means far less dirt needs removal, saving millions in disposal costs. The company started in 2016 with a focus on solving urban traffic gridlock. Its first significant achievement was a test tunnel. This tunnel was in Hawthorne, California, directly beneath SpaceX property. It was completed in 2018 after nearly 2 years of work. This test showed their initial capabilities and engineering prowess. It was a 1.15-mile tunnel, a considerable length for a first attempt. People could ride through it in Tesla vehicles modified with deployable guide wheels. This initial demonstration gave a glimpse of their ambitious vision for urban travel. The tunnels are typically 12 feet in diameter. This size is enough for one car or public transport pod to move safely. The vehicles travel on dedicated electric skate systems, or sometimes they are just Teslas on their own wheels, driven by human operators for current safety protocols. The zero emissions within the tunnels are a key environmental benefit, keeping urban air clean. Their most known project is the Las Vegas Convention Center Loop. It is called the LVCC Loop. This system serves the enormous 4.7 million square feet convention center complex. It has 3 passenger stations strategically spread across the campus for maximum accessibility. The loop itself is 2.7 miles long, forming a vital internal transport network. It opened for public use in 2021 after a swift construction period. The LVCC Loop moves a lot of people every day of operation, often during peak convention times. It can transport 4,500 passengers per hour, greatly enhancing attendee mobility. This speed greatly reduces walking times across the huge campus. Imagine walking for 45 minutes between convention halls in the desert heat. Now imagine riding for just 2 minutes instead in a cool electric vehicle. That is a massive saving in time and energy for thousands of attendees and exhibitors. The cost for this entire system was $47 million, a relatively low price for such infrastructure. This figure includes the tunnels and stations and all operating equipment. There are about 100 Tesla vehicles running within the loop. These cars are currently driven by human operators for safety and initial system proving. Full automation is the long-term plan for greater efficiency and reduced operational costs. This project showcased a practical application of their technology. It proved that fast underground transportation could work reliably. It also demonstrated the ability to complete such infrastructure quickly and within budget. Convention attendance has already benefited from this improved access and convenience. The economic impact on Las Vegas is noticeably positive with more successful events. The bigger dream for Las Vegas is the Vegas Loop. This project is far more ambitious and expansive. It plans for 29 miles of tunnels. It will have 51 stations. These stations will connect 55 different destinations across the city. Think hotels, casinos, the airport, and the famous Las Vegas Strip Entertainment District. This vast network could dramatically reduce surface traffic on already congested roads, especially on busy weekends. The estimated cost for the Vegas Loop is between $500 million and $1 billion, an investment of considerable scale. This project is much bigger than the LVCC Loop, by far a truly citywide solution. Phase 1 of the Vegas Loop covers 3.4 miles. It includes 5 stations servicing key tourist areas. This phase alone could carry 90,000 passengers per hour during peak demand. This massive capacity would transform urban mobility for Vegas visitors and residents alike. It would allow faster travel between major tourist attractions and business hubs. Imagine cutting a 20-minute taxi ride down to 5 minutes, or even less. This kind of efficiency could change tourism logistics completely, making visits much more enjoyable. Building these tunnels is a complex engineering feat. The ProofRock machine is their latest tunneling device. This machine is designed to dig faster and more autonomously. The company hopes ProofRock can achieve its target speeds regularly. Their ultimate goal is 1 mile of tunnel per week. Reaching this speed would be revolutionary in the construction world. It would mean digging 52 miles of tunnel in just 1 year, a record-breaking pace. Currently, their progress is slower, perhaps around 1/10 of that target speed for now. But they are always improving their methods and machine designs with each new iteration. ProofRock features a continuous mining process. This means it can dig and reinforce the tunnel lining simultaneously without interruption. This simultaneous action is a key part of their claimed speed advantage. Traditional machines often stop to install tunnel segments, a time-consuming process. ProofRock does not stop for this critical step, it just keeps moving forward. It is truly revolutionary. There are many challenges for the boring company moving forward. Regulatory hurdles are a big one, slowing progress significantly. Getting permits for underground construction is often very slow and complicated across different municipalities. Each city has its own set of rules and environmental assessments to navigate. Public perception also plays a role in public acceptance and political will. Some people question the practicality of car tunnels as a primary solution. They wonder if this is the best solution for urban traffic problems. Critics argue that adding more car capacity simply encourages more driving, leading to new congestion elsewhere. This phenomenon is known as induced demand. Scaling up operations is another massive challenge, requiring immense logistical coordination. Digging 1 or 2 tunnels is vastly different from hundreds of miles of interconnected network. Financial viability is always a concern for such huge infrastructure projects. The initial investment costs are enormous, even with their claimed cost reductions. Convincing investors and cities of long-term returns is crucial for future expansion. Safety during construction and operation is paramount and non-negotiable. Preventing collapses and ensuring air quality inside tunnels are critical for any underground system. Integrating emergency exits and robust ventilation systems is crucial for passenger safety and peace of mind. Elon Musk often emphasizes the environmental benefits of these systems. Electric vehicles inside tunnels mean 0 local emissions, a huge plus. This is good for air quality in crowded cities, especially those with persistent smog problems. Reduced surface traffic could also lead to more green spaces above ground over time. The idea is to reclaim city streets for pedestrians and bikes, enhancing urban living. This vision aligns with many modern sustainability goals and urban planning efforts. But reaching this scale requires huge commitment and investment from many stakeholders. It is a long-term play that requires consistent political and public support for decades. The company has explored other projects too for various metropolitan areas. A proposed tunnel under Los Angeles was considered for several years to ease freeway congestion. A Chicago O'Hare Express tunnel also gained significant attention a few years ago. There was even talk of a tunnel connecting Washington, D.C. and Baltimore for high-speed travel. These projects faced various obstacles and bureaucratic delays. Community opposition, funding issues, and regulatory complexities often stall progress indefinitely. The DC-Baltimore project, for example, aimed for an incredibly fast transport system called Loop. It envisioned people traveling at 150 miles per hour in special autonomous pods. This speed would cut travel times dramatically from 2 hours to perhaps 15 minutes, a truly transformative change. But such proposals require immense capital and political will to move forward and become reality, the Washington, D.C. Tunnel permit was granted in 2018 for a test section. However, progress has been slow on that front with no major construction. The Chicago project involved a $1 billion proposal to connect downtown to O'Hare Airport in 12 minutes. That plan eventually fell through due to a change in city leadership and priorities. These examples show the difficulties of large-scale infrastructure development. The concept of a 3-dimensional transport network is central to Musk's thinking. Instead of building up or out horizontally, we dig down. This frees up valuable surface space for other uses. It also allows for direct point-to-point travel underground. This reduces detours and travel times significantly for commuters. It is a bold vision against the traditional two-dimensional road network of today. Imagine bypassing all surface-level traffic lights and junctions and never stopping. This would save countless hours of commuting time for millions every day. And it could make cities much more livable by reducing noise pollution and visual clutter from vehicles. The freedom from traffic lights and stop signs means continuous movement and maximized efficiency. This continuous flow is what enables the high speeds and high capacity in their systems. The future plans for the Boring Company involve refining their technology even further. They aim to make the tunneling process fully automated, requiring minimal human intervention. This would further reduce costs and increase speed even more dramatically. Developing specialized autonomous vehicles for the tunnels is also key to their long-term vision. These vehicles could be smaller and more efficient than regular cars, maximizing tunnel capacity, or they could be platforms for public transit, moving many people at once. The promise of a traffic-free future continues to drive their innovation. It is an incredibly ambitious undertaking, one that could change urban landscapes forever if successful on a grand scale. But the path ahead is long and filled with many obstacles and engineering challenges. The engineering and financial scale is truly immense, requiring sustained effort and funding. Their success could redefine how we move around large metropolitan areas and solve congestion. This is a game-changing idea if it works as intended, with enough investment and patience from all involved. The shift from human-driven vehicles to autonomous pods is a large technological leap itself. It promises even greater capacity and safety within the tunnels, making them incredibly efficient. This would provide a reliable, consistent travel experience for everyone using the network.